July 29th, 1944. The signal came through on a diplomatic cable marked with the highest classification. In a secure research facility tucked into the pine forests outside Rechlin, Germany, a team of engineers gathered in a room where the windows had been painted black. Chief Engineer Dr. Wilhelm Falkenberg stood at the head of a mahogany table, his hands steadying a roll of photographic paper that refused to lie flat. The room smelled of chemicals and cigarette smoke and fear. Outside, the late summer sun filtered through the trees. Inside, the world was about to change. They called it the Haniva Project, named for a seaside town where German intelligence once intercepted British radio signals. The project had a single purpose: understand the Boeing B-29 superfortress. What they knew came in fragments: aerial reconnaissance photographs taken from 80,000 feet, too distant to show detail. Radio intercepts from the Pacific, garbled by static and code. Pilot reports from Japanese aviators who had encountered the bomber and lived to describe it. Until now, these pieces had formed only a ghost of an aircraft, an abstraction, a rumor of American power. The photographs Dr. Falkenberg unrolled changed everything. They showed an aircraft on a Soviet airfield. Not shot down, not crashed, landed, intact. The crew had been forced to set down in Vladivostok after engine trouble over Manchuria. The Soviet Union, still bound by neutrality treaty to Japan, had interned the 10-man crew and seized the aircraft. What the Japanese knew, they shared with their Axis partners. What the Soviets allowed the Germans to see, however briefly, became the foundation of a nightmare. The B-29 sat on frozen ground, its silver skin reflecting a pale Arctic Sunday. The photographs, taken with a Leica camera by a Soviet technician who would later disappear into the Gulag, showed details that made the German engineers lean closer. The wingspan measured 141 feet. The fuselage stretched 99 feet. But numbers alone did not convey the presence of the thing. It looked less like an aircraft than a statement of intent. Dr. Erich Weber, the young propulsion specialist, reached for a magnifying glass. His hand brushed the photograph surface. "This is impossible," he whispered. The engine nacelles housed Wright R-3350 duplex Cyclone radial engines, 18 cylinders, 2,200 horsepower each. The B-29 carried 4 of them, but the photographs showed something else, something that made Weber's training rebel against the evidence of his eyes. The engines were turbo-supercharged, not mechanically supercharged like the BMW 801s in the Focke-Wulf 190, turbo-supercharged, using exhaust gases to compress incoming air, allowing the bomber to maintain power at altitudes where German fighters gasped for breath. The implications spread across the table like a toxin. The B-29 could operate at 31,000 feet. At that altitude, it flew 100 miles per hour, faster than any German bomber. It carried 20,000 pounds of bombs, 20,000. The Heinkel He 177 Greif, Germany's most advanced heavy bomber, could manage at most 13,000 pounds, and that only after sacrificing fuel and crew armor. The B-29's range exceeded 3,000 miles. It could fly from Saipan to Tokyo and back, from Britain to Berlin and return with fuel to spare. But the most devastating revelation waited in the 6th photograph. In the 6th image, a Soviet technician had pried open an access panel near the bomber's nose. The camera flash revealed a labyrinth of ducts, valves, and analog instruments that none of the German engineers recognized at first glance. Then, slowly, the understanding came. The B-29 was pressurized. Dr. Helmut Schenkel, the team's aeromedical specialist, stood up so quickly his chair toppled backward. "Show me the crew compartment," he demanded. The photographs revealed a continuous pressurized tube running 2/3 of the bomber's length. Crew members moved between stations without oxygen masks. They sat in heated comfort while the outside temperature dropped to -50 degrees Fahrenheit. The Germans had experimented with pressurization. The Junkers Ju-86 reconnaissance aircraft used it in limited form. But to pressurize a bomber this size? To maintain structural integrity with a pressure differential of 8.5 pounds per square inch across 99 feet of aluminum alloy, Schenkel calculated the engineering requirements in his head. The fuselage needed circular cross-sections, Stress concentrations had to be eliminated at every window, every door, every gun port. The aluminum alloy, 24 steel heat-treated, had to be formed with tolerances measured in thousandths of an inch. A single flaw, one imperfect rivet, would cause explosive decompression at combat altitude. The photographs showed the solution. The gun turrets were not manned. They were remote-controlled. The B-29 carried 10 50-caliber machine guns in 5 turrets. In German aircraft, gunners sat in open cockpits, exposed to the slipstream, dependent on their own eyes and reflexes. In the American bomber, General Electric analog computers sighted the weapons. Gunners in pressurized comfort looked through periscopic sights, their targeting data fed by gyroscopic sensors and airspeed indicators. The system compensated for bullet drop, wind drift, and target motion automatically. It could track fighters attacking at 400 miles per hour and calculate firing solutions in microseconds. The Germans had nothing like it. Their experiments with remotely controlled turrets had failed. The technology required precise synchronization between hydraulic actuators and electronic controls. It required voltage regulation that remained stable at 60 degrees below zero. It required manufacturing consistency that seemed beyond human capability. Dr. Falkenberg lit a cigarette, his first in 3 hours. The match shook so badly he nearly burned his thumb. "Gentlemen," he said, his voice dry as old paper, "we are not looking at an aircraft. We are looking at an industrial ecosystem." 3 weeks later, the team submitted their report. It ran 470 pages and included supplemental material from the Abwehr, the Foreign Office, and the Reich Ministry of Armaments. But the numbers that mattered came from a single source, a defector, a German-American who had worked at Boeing's Wichita plant before the war. His name was Otto Kohler. He had fled to Germany in 1938, disillusioned with the New Deal. Now his conscience troubled him. He sat in a Gestapo interrogation room in Hamburg and described something the German engineers could scarcely comprehend. "Building the B-29 wasn't manufacturing," he said through a translator. "It was choreography." Kohler described the Boeing plant in Wichita, a building so large that clouds formed beneath its roof. Assembly lines that moved not by inches but by feet per minute. Sub-assemblies arriving from a network of suppliers that stretched across 40 states. Wright Aeronautical in New Jersey built the engines. Pratt & Whitney in Connecticut competed with improved designs. The pressurized cabin sections came from a factory in Seattle that had previously built refrigerators. The analog computers came from a company in Iowa that made cash registers before the war. Each B-29 contained 165,000 individual parts. Boeing had learned to produce one every 90 minutes. The German engineers did the math. There were 24 hours in a day, 7 days in a week. Allowing for maintenance and crew changes, the Wichita plant could theoretically produce 160 bombers per month. The Renton plant matched that. Together, with overtime and expanded shifts, they could reach 300 per month. But that was only the beginning. Albert Speer, the Minister of Armaments, read the Hanover Report on the morning of August 15th. He had come to his office at 4 a.m., as was his habit, and the report waited in a red folder on his desk. He read it twice, then summoned his deputy. Speer understood what the engineers did not. The B-29 was not a failure of German engineering. It was a triumph of American organization. Speer had visited American factories in 1937 as part of a study tour. He had seen the Ford plant at Willow Run producing B-24 Liberators. At the time, he had been dismissive. The American method seemed crude. Workers performed simple, repetitive tasks. There was no craftsmanship, no pride in individual creation. Each man tightened 3 bolts and passed the wing spar to the next station. The Germans, by contrast, built aircraft in bays, where teams of skilled machinists and fitters assembled entire sections from raw materials. German workers understood their machines intimately. They could adjust, improvise, improve. Speer now understood the terrible price of that intimacy. The German system produced masterpieces. The Focke-Wulf 190 was a superb fighter. The Messerschmitt 262 jet was a revolutionary design, but each was essentially hand-built. German factories produced fighters in the hundreds per month. The Americans produced them in thousands. The Haniva report included an intelligence estimate from the Abwehr, based on factory output data, aluminum production figures, and workforce numbers. The Americans could build B-29s at a rate of 100 per month by the end of 1944, 200 per month by spring of 45. With full mobilization of their automotive industry, with Ford and General Motors converted completely to aircraft production, that number could reach 500 per month. 500 B-29s per month, each capable of carrying 20,000 pounds of bombs across 3,000 miles. That meant 10 million pounds of ordnance delivered per month, to any target within 3,000 miles of an American base. Berlin was 1,200 miles from Britain. Tokyo was 1,500 miles from Saipan. There was no place in the world that would be safe. But the report's final paragraph contained the number that would haunt Speer's dreams, the number that would end up on Hitler's desk, circled in red pencil, accompanied by a note from Martin Bormann suggesting the report's authors were defeatists. The number that would lead to Dr. Falkenberg's reassignment to a rocketry project at Peenemünde, where he would eventually surrender to American forces. The number was 10,000. 10,000 B-29s per year. The figure came from Kohler, the defector. He explained it carefully, as though describing a miracle of faith. The American automotive industry, he said, had been designed from its inception for mass production. The Boeing assembly line was just one node in a network. The final assembly plant was a place of marriage, where components came together like bride and groom. But the true production happened elsewhere. The Wright engine factory in Paterson, New Jersey, employed 15,000 workers on 3 shifts. They produced 1,000 R-3350 engines per month. Each B-29 needed 4 engines, but engines wore out. Combat losses claimed them. Training accidents destroyed them. The Americans planned for attrition. They built 4 engines for every airframe. The aluminum alone required an industrial cascade. Alcoa's plant in Messina, New York, ran on hydroelectric power from the St. Lawrence River. It produced 200,000 tons of aircraft-grade aluminum annually. The sheets were formed in Pittsburgh, heat-treated in Cleveland, machined in Detroit. The rivets, millions of them, came from a factory in Connecticut that had made safety pins before the war. Kohler described the workforce. Not master craftsmen, but ordinary Americans. Housewives from Kansas who learned to rivet in 2 weeks. Former grocery clerks who became experts in hydraulic systems. Farm boys from Nebraska who could align a bomb sight to within 1/10 of a degree. The Army Air Force's Training Command produced 10,000 new mechanics per month. The Aircraft Mechanics School in Wichita alone graduated 3,000 every 6 weeks. Give America 3 years, Kohler said. And they could have 10,000 B-29s. Give them 5 years, and they could have 20,000. The limitation isn't materials or money or will. It's time. Speer calculated the German equivalent. The Heinkel He-177 program had produced 1,189 aircraft total. Each required 8,000 man-hours to build. The B-29 required 57,000 man-hours, but those hours were spread across a workforce of 2 million people simultaneously. The German aircraft industry employed 600,000 workers, total. They produced fighters and bombers and transports for every front. They were already operating at maximum capacity, in shifts that left workers exhausted and prone to error. The American economy, by contrast, was operating at 40% capacity. Their automotive industry, the largest in the world, was still building trucks and jeeps and tanks. When those factories switched completely to aircraft production, the output would increase not incrementally but exponentially. 10,000 B-29s was not an estimate, it was a flaw. On the afternoon of August 20th, a special briefing convened at the Luftwaffe High Command in Berlin. Field Marshal Erhard Milch, responsible for aircraft production, stood before a projection screen. Behind him, photographs of the B-29 cycling on a slide projector. The room held 24 men, fighter aces, bomber commanders, designers from Focke-Wulf and Messerschmitt, young pilots who had grown up in the Hitler Youth and now faced a future they had not imagined. Milch did not mince words. The Americans have built a bomber that makes our He-177 look like a kite. They can build 10,000 of them. We must assume they will. The fighter pilots shifted uncomfortably. General Adolf Galland, sitting in the back with his trademark cigar, studied the photographs with the eye of a man who had shot down 104 enemy aircraft. He saw immediately what Milch was implying. At 31,000 feet, the B-29 flew above the service ceiling of the Messerschmitt 109. The Focke-Wulf 190 could reach that altitude, but its performance degraded severely. The new jet fighters, the 262 and the 163, could climb that high. But they were just entering service. There were perhaps 50 operational jets in the entire Luftwaffe. The American bombers' remote turrets tracked targets at speeds no human gunner could match. The analog computers linked to radar warning receivers. A German fighter approaching from behind would be detected at 2 miles. The tail turret would begin tracking at 1 mile. At 400 yards, the system would open fire with 2 50-caliber machine guns, stabilized and computer-aimed. The probability of a hit exceeded 60%. Galland did the tactical calculation. To attack a formation of B-29s, a German pilot would need to climb through a defensive barrage of 500 guns per squadron. The Americans flew in combat boxes, their fields of interlocking fire creating a sphere of death 2 miles in diameter. The B-29 carried a combat load of 10,000 pounds of bombs in typical configuration. That meant 4 1,000-pound high-explosive bombs, plus incendiaries. The Americans had demonstrated in Japan what incendiaries could do to cities built of wood and paper. German cities were built of stone and brick, but the fires would burn anyway. The young pilots in the room had been trained to believe in German technical superiority. They had flown against the B-17 Flying Fortress and the B-24 Liberator. They knew those bombers could be shot down. The Flying Fortress carried 13 50-caliber guns, all manned. It flew at 25,000 feet. It was vulnerable. The Superfortress was something else. It was not a target. It was a weather system. It altered the tactical environment simply by existing. To plan an attack on a B-29 formation, Galland realized, was to plan a battle where your own losses would likely exceed 50%. For every bomber you shot down, you lost 2 fighters. For every 100 bombers destroyed, you lost the entire fighter arm of a Luftflotte. And the Americans could send 1,000 bombers. 2,000. 10,000. Hermann Göring received the Hanover Report on August 22nd. He read it in his hunting lodge at Carrenhall, surrounded by the trophies of conquest. Paintings looted from Paris, sculptures from Warsaw, tapestries from Amsterdam. The report felt like poison. He threw it across the room, then retrieved it, smoothing the pages with trembling hands. He had promised Hitler 1,000 bombers. He had delivered excuses. Now this American wonder appeared, and Göring understood with finality that the war was lost. He summoned his chief of staff. "Tell Speer," Göring said, his voice hollow, "that the Luftwaffe requires a new heavy bomber. Specifications must exceed the B-29. We need it in production within 1 year." The chief of staff, a colonel named Karl Koller, had served under Göring since the Polish campaign. He had seen the Reichsmarschall at his best and worst. He recognized the tone. This was not an order. It was a confession. Koller knew what every engineer in the room knew. Germany could not build such an aircraft. Not in 1 year. Not in 5. They lacked the aluminum. They lacked the workforce. They lacked the organizational capacity. They lacked everything except the will, and will alone could not bend aluminum alloy. The America bomber program had produced nothing but prototypes. The Messerschmitt 264 had flown, but its range fell short by 1,000 miles. The Junkers 390 had better range but carried half the bomb load. The Heinkel 277 existed only on paper. Each design required engines that Germany could not produce in quantity. Each required advanced materials that had been diverted to the V-2 rocket program or the Panzer divisions or the submarine fleet. The German economy was a zero-sum game. Every ton of aluminum for a bomber meant 1 less fighter. Every skilled machinist meant 1 less tank. The B-29 represented the opposite philosophy. America did not choose between guns and butter. They produced both in staggering quantities. They built bombers and battleships and tanks and trucks and still had steel left over for washing machines and refrigerators. The American economy was not zero-sum, it was an expanding universe. Koller delivered Goering's message to Speer. The armaments minister listened in silence, then opened a drawer in his desk. He withdrew a single sheet of paper. It showed production figures for the American automotive industry. In 1941, American car companies had built 4 million vehicles. In 1942, they built 139, not because they lacked capacity, but because they had converted every assembly line to war production. Ford's Willow Run plant, designed to build B-24 Liberators, would eventually produce 1 bomber per hour. Not per day. Per hour. If we had started 3 years ago, Speer said softly, we might have had a chance. Now, we can only delay the inevitable. On September 1st, the engineering team at Rechlin completed their final assessment. They titled it simply, B-29 Analysis, Industrial and Military Implications. The cover page bore no swastika, no eagle, no national symbol, just the title and the date. It was as if the authors had already begun thinking in terms of a future Germany, a defeated Germany, that would need to understand how it had been beaten. The report's technical section ran 200 pages. It detailed the B-29's structure, its systems, its subsystems, its components. But the final chapter, only 12 pages long, contained the true message. It was titled, Production Potential. Weber, the propulsion specialist, had written the draft. Schenkel had edited it. Falkenberg had approved every word. They wrote with the precision of men who knew their careers, perhaps their lives, depended on clarity. Based on analysis of American industrial capacity, aluminum production, workforce availability, and demonstrated assembly techniques, we estimate that the United States can produce B-29 bombers at the following rates. Current production, August 1,944. 50 aircraft per month. Projected production, January 1,945. 120 aircraft per month. Maximum sustained production, Lend-Lease scenarios, 300 aircraft per month. If automobile production is fully converted, 500 aircraft per month. In a total war economy, with all civilian manufacturing suspended, 1,000 aircraft per month. At this maximum rate, the United States would produce 12,000 B-29s per year. More realistically, allowing for American insistence on maintaining civilian standards of living, the sustainable rate is between 8,000 and 10,000 aircraft annually. The report noted what these numbers meant in practical terms. 10,000 B-29s, each carrying 20,000 pounds of bombs, represented 200 million pounds of ordnance delivery capacity per mission. A single raid by 100 B-29s could drop 1 million pounds of bombs. 1,000 bombers could drop 10 million pounds. The saturation point of German air defences, the report calculated, was reached at approximately 300 bombers in a single raid. Beyond that number, the defensive firepower overwhelmed attacker tactics. Loss ratios inverted. More attackers survived than defenders. The Luftwaffe had approximately 2,000 operational fighters in September 1944. On paper. In reality, perhaps 1,000 were combat-ready on any given day. A single raid by 500 B-29s, protected by 1,000 long-range escort fighters, would destroy 50% of German interceptor strength. 2 such raids, spaced 1 week apart, would effectively eliminate the Luftwaffe as a defensive force. The Americans could fly those raids daily. Word spread through the German high command with the velocity of rumor. A clerk in Speer's office mentioned it to a secretary. The secretary told her brother, a captain in the Signals Corps. He transmitted it in a secure message to his commander. Within 2 weeks, every senior officer in the Wehrmacht knew that America could build 10,000 B-29s. Most dismissed it as propaganda. German intelligence had been wrong before. They had underestimated the Soviet 34 tank. They had misunderstood the British radar network. This was simply another intelligence failure. another exaggeration of American capabilities. But the engineers knew. The men who had designed the He-177, who had struggled with its engine fires and structural weaknesses, who had watched their America bomber dreams collapse under the weight of technical impossibility, they recognized truth when they saw it. They had spent their careers pushing German technology to its absolute limits. They knew exactly what was possible and what was not. The B-29 was possible because American industry had made the impossible routine. In a drafting office in Dessau, where the Junkers design team worked on the Ju-287 heavy fighter, a senior engineer named Alfred Gassner gathered his staff. He showed them the Hanover report. They read it in silence. One young designer, a party member who had never known doubt, threw the report on the floor. "Lies," he shouted. "American capitalism is decadent. They cannot organize such production." Gassner, a veteran of the First World War, waited until the young man finished. Then he spoke quietly. "I have seen their factories. In 1936, I attended an aviation conference in Detroit. They took us to the Ford plant. They were building a car every 40 seconds. Not identical cars, customized cars, different colors, different interiors, different options, 50,000 workers, a supply chain that stretched across an entire continent. What they did for cars, they can do for bombers. The only question is whether they have chosen to." He paused, looking at his team. "They have chosen to. The war is over. We simply haven't stopped fighting yet." The last photograph in the Hanover report showed the crew, 10 men, standing in a row before their aircraft. They wore leather jackets and confident smiles. They looked impossibly young. The navigator, a second lieutenant named James D'Angelo, was 22 years old. The tail gunner, Sergeant Walter Nowak, was 19. The aircraft commander, Captain Robert Morgan, was 25. They looked like university students on holiday. The German bomber crews were older. They had to be. Flying the He-177 or the Ju-88 required years of training. The Americans had compressed that training into months. They had standardized procedures so that any crew member could be replaced. The aircraft were designed for average pilots, average navigators, average gunners. German aircraft required mastery. American aircraft required attendance. This was perhaps the most subtle and devastating advantage. The German system produced brilliant individualists. The American system produced interchangeable experts. When a German bomber crew was lost, its experience died with it. When an American crew went down, a replacement crew stepped in, trained to the same standard, able to operate the same machine with the same efficiency. The Hanover report estimated that the United States Army Air Force's Training Command graduated 1,000 new bomber crews per month. Each crew required 6 months of training. The pipeline never stopped. If losses reached 50% per mission, the Americans could still increase their bomber force month by month. The Luftwaffe, losing pilots at a similar rate, shrank irreversibly. Every German ace shot down was irreplaceable. Every American pilot lost was a statistic. Dr. Schenkel wrote a personal letter to his wife, which she would burn after reading. "My dearest Anna," it began. "Today I saw the future, and it wears a leather flight jacket and carries a slide rule. Our children, if they survive this war, will live in a world where German engineering is a footnote. The Americans have discovered the secret that eluded us. They build not for perfection, but for production. Quantity has a quality all its own. I wish I had understood this sooner." On October 2nd, Dr. Falkenberg presented the Hanover report to a select committee of the Reich Research Council. The room was underground, beneath the Reich Chancellery, protected by 60 feet of concrete and steel. The men who listened were not soldiers. They were scientists, physicists who worked on the atomic project, chemists who developed synthetic fuel, mathematicians who calculated ballistic trajectories. They understood numbers. Falkenberg's presentation lasted 3 hours. He showed the photographs. He detailed the specifications. He explained the production analysis. He described the training programs. When he finished, the room was silent. Then Hans Kammler, the SS officer overseeing advanced weapons development, stood. He wore his black uniform like armor. "Dr. Falkenberg," he said, his voice soft and dangerous, You are telling us that we cannot compete. I am telling you, Falkenberg replied, meeting Kamler's gaze, that we have never competed. We have fought a different war. We fought for quality. They fought for quantity. We built the finest swords. They built the finest factories. The swordsmith always loses to the industrialist. Kamler's hand moved to his holster, a gesture he did not complete. Instead, he smiled. Then we must build better swords, faster swords. The 262 jet can catch this bomber. The 163 can destroy it. The V2 rocket can reach their factories. Falkenberg nodded slowly. Yes, we can build a jet that flies 500 miles per hour. We can build a rocket that reaches 60 miles high. How many can we build? 100 jets? 200 rockets? They can build 10,000 bombers. Each bomber can drop 20,000 pounds of bombs. That is 200 million pounds of bombs. How many V2s would we need to stop them? How many jets? He let the question hang. No one answered. The mathematics were stark. A V2 cost as much to produce as two B-29s. It carried a 1-ton warhead. It was inaccurate. It could not reliably hit a factory. It could not stop production. The jets were faster than the bombers but had limited range. They could defend German airspace but could not reach American factories. The scientists understood. The game was over. They were playing chess, and the Americans were playing a different game entirely, a game of industrial attrition where every German piece removed from the board cost 1,000 American pieces, and America could replace its losses while Germany could not. The actual production numbers tell a story more modest than the German fears, but no less impressive. Between 1943 and 1946, American factories built 3,970 B-29 superfortresses, not 10,000 per year, 4,000 total, but the fear was real. And the potential was real. And in the final analysis, the difference between 3,970 and 10,000 was simply a matter of time and will. America had both. The Boeing plant at Wichita peaked at 175 aircraft per month. The plant at Renton reached 150. Together, they built 325 bombers in the best month of the war, September 1945. That was after the war ended, after the contracts had been cut, after the urgency had diminished. In the last 6 months of the war, production increased month by month. The curve was exponential. Given another year of war, the German estimate of 10,000 annually would have proven conservative. Each bomber required 6 tons of aluminum. For 3,970 bombers, that was 23,820 tons of aluminum. America produced 1 million tons of aluminum in 1944 alone. The constraint was not material. It was not labor. It was simply the time required to build the factories, train the workforce, and perfect the assembly process. The Germans had started building the He-1 177 inches 1939. It entered service in late 1942, 3 years later. The B-29 was designed in 1940 and first flew in September 1942. It entered combat in June 1944, 4 years from drawing board to war. But in those 4 years, America had not simply designed a bomber, it had designed the means to produce bombers in numbers that defied imagination. The psychological impact of the Hanover Report cannot be overstated. It arrived at a moment when German morale was already cracking. The Soviets were advancing in the east. The Allies had broken out of Normandy. The V1 campaign against London had failed to force a peace. The V2 campaign was just beginning but would prove equally futile. The report told the German leadership something they already suspected but could not admit. America was a sleeping giant that had not yet fully awakened. The war in the Pacific consumed perhaps 30% of American industrial capacity. The war in Europe consumed another 30%. 40% of America's economy still served civilian needs. Gasoline was rationed but not eliminated. Meat was scarce but not absent. Hollywood still made movies. Baseball still filled stadiums. America was at war, but not consumed by it. The report's classified distribution included a note from the Abwehr chief, Wilhelm Canaris. He wrote in pencil, in the margin of page 212, "They build because they can, we build because we must. The difference is everything. Canaris, who would be executed in April 1945 for his ties to the resistance, understood what his colleagues did not. The American system was self-sustaining. It built bombers because bombers served a strategic purpose, but it could just as easily build automobiles or refrigerators or any other product of industrial civilization. The German system was extractive. It built weapons because it had to, because the entire national project depended on military success. When the weapons failed, the project collapsed. When the Americans built a flawed bomber, they built another and another until the flaws were eliminated. This was the hidden strength of democracy at war. It was not more ruthless, it was more resilient. FDR could be voted out, Hitler could not. American generals who failed were replaced. German generals who failed were shot. The American system was inefficient, argumentative, slow to decide. But once decided, it moved with a momentum that totalitarianism could not match. Totalitarianism demanded success. Democracy could afford failure. Dr. Falkenberg survived the war. He was captured by American forces in May 1945 and taken to a prisoner of war camp in England. In July, an American officer visited him. The officer was a colonel in the Army Air Forces, a former Boeing engineer named James Woods. He brought a gift, a technical manual for the B-29. "I thought you might want to see what you were up against," Woods said. Falkenberg spent 3 days reading the manual. He discovered that the Hanover report had been accurate in every important particular, but had still underestimated the bomber's capabilities. The pressurization system was more robust than estimated. The remote turrets were more precise. The engines, despite early problems with overheating, had been refined to a level of reliability German engines never achieved. Woods returned on the 4th day. "Your report was impressive," he said. "We captured a copy in Berlin. You got most of it right." Falkenberg looked up from the manual. "The 10,000 per year?" Woods smiled. "That scared the hell out of us, frankly. We knew we could build them, but we didn't know you knew. Your intelligence was better than we thought." "The number was theoretical," Falkenberg said. "A calculation of potential." "Yes," Woods agreed. "But potential has a way of becoming real. We built nearly 4,000. That was enough. More would have been redundant. But we could have built 10,000. We had the plants planned. The workforce was available. The only thing that stopped us was victory." Falkenberg closed the manual. "Victory," he repeated, "or defeat, depending on which side you're on." After the war, Falkenberg emigrated to the United States. He took a job with Lockheed, working on the C-130 Hercules transport. He never worked on bombers again. In an interview late in life, he was asked about the Hanover report. "We thought we were building weapons," he said. "We were building museum pieces. The Americans were building a production system that could make anything, including peace. That was the real miracle of the B-29. It wasn't a bomber, it was a promise. The promise that whatever the world needed, American industry could provide. In quantity, in quality, and on time. The deeper meaning of the B-29 revelation lies not in the technical specifications or the production numbers, but in what those numbers represented about the nature of modern warfare and industrial society. The German engineers, trained in the European tradition of craftsmanship and precision, could not initially comprehend that a bomber built by factory workers in 90 minutes could be superior to one built by master craftsmen in 2 months. They believed that quality resided in the individual maker. They discovered that quality could be engineered into the system itself. This was the American innovation. Not the pressurized cabin. Not the remote turrets. Not even the mighty R-3350 engine. The innovation was the understanding that in industrial warfare, consistency trumped perfection. A bomber that flew 99 times out of 100 was better than one that flew perfectly once. A weapon built by 10,000 workers was better than a masterpiece built by 10 masters. The German war economy, for all its organizational brilliance under Speer, remained rooted in the artisanal tradition. German tanks were superbly engineered. The Panther tank was arguably the best medium tank of the war. But Germany built 6,000 of them. America built 50,000 Sherman tanks. The Sherman was inferior in armor and gun. It was also reliable, repairable, and replaceable. A Panther disabled in battle was often abandoned because the Germans lacked the spare parts and recovery vehicles to retrieve it. A Sherman disabled could be repaired in the field with standardized parts and returned to service within days. This philosophy of replaceability extended to the B-29. When a superfortress was damaged beyond repair, it was not mourned. Another took its place. The crew was another matter. American bomber crews suffered ghastly casualties. In the early days of the Pacific bombing campaign, loss rates reached 60% per mission. But the crews kept coming. The training pipeline produced replacements. The bombers kept flying. The American public, insulated from the direct effects of war by distance and oceans, accepted these losses because the industrial system absorbed them. The Germans had no such luxury. Every loss was keenly felt. Every setback was personal. The war was fought on German soil, in German skies, with German blood. The B-29 represented not just a technical or industrial challenge, but a moral one. How does a nation continue to fight when it understands that its enemy can replace losses indefinitely, while it cannot? The true strategic impact of the German realization about B-29 production potential can be measured not in what happened, but in what could have happened. The Hanover Report imagined a scenario that never came to pass. Germany surrendered in May 1945. The B-29 force that had bombed Japan numbered fewer than 1,000 aircraft. The 10,000 bomber armada existed only in German nightmares, but those nightmares shaped decisions. The report influenced the allocation of resources to the V-2 program on the theory that rockets could strike American production centers that bombers could not reach. It accelerated the jet fighter program, leading to rushed deployments of the 262 and 163 that consumed scarce aviation fuel. It contributed to the faith placed in the Type 21 submarine, a technological wonder that could not be built in numbers sufficient to alter the Battle of the Atlantic. Perhaps most significantly, the report helped create the psychological conditions for the continuation of the war long after rational calculation suggested surrender. If America could build 10,000 bombers, then Germany's only hope was a miracle weapon. The atomic bomb program, never a serious priority for Hitler, received renewed attention. The V-3 supergun, the wind cannon, the sun gun, the maze of Wunderwaffen projects that consumed Germany's last resources, all stemmed from the despair that the Hanover Report crystallized. When conventional victory becomes impossible, unconventional desperation becomes policy. The tragedy for Germany was that the miracle weapons, even if they had worked, could not have changed the fundamental equation. A V-2 rocket hitting New York would not stop the assembly lines in Wichita. An atomic bomb destroying Washington would not eliminate the industrial capacity of Detroit. The American system was decentralized, resilient, self-repairing. It was not a snake that could be killed by cutting off its head. It was a hydra that grew 2 factories for every one destroyed. We return to the photograph of the crew. 10 young men who represented the human face of industrial warfare. They did not build the bombers. They did not design the computers. They did not mine the aluminum or forge the steel. They simply operated the final product. But their presence in the Hanover Report was not accidental. The German engineers needed to understand not just the machine, but the men who flew it. These were not the fanatical pilots of Japanese kamikaze squadrons, willing to die for the emperor. They were not the ideologically pure aviators of the Luftwaffe, sworn to die for Führer and fatherland. They were citizens of a democracy, flying because their country asked them to, returning home when their tours were complete, expecting to survive. The B-29 was designed with this expectation in mind. It was armored, it was pressurized. It was festooned with defensive guns precisely because American doctrine assumed crews would face multiple missions and return to fly again. German bomber design, by contrast, assumed high attrition. The He-177 had no ejection seats. The crew compartments were not armored. If the aircraft was hit, the crew was expected to fight until they died. This was not cruelty. It was realism. German bombers could not be built in numbers sufficient to provide replacement crews. Each mission was, in effect, a suicide mission. The aircraft were disposable because they were irreplaceable. When the German engineers examined the B-29, they saw not just a bomber but a system of values encoded in aluminum. The pressurization said, "We value your comfort and efficiency." The remote turrets said, "We will protect you with technology." The standardized parts said, "If you are damaged, we can repair you." Everything about the aircraft spoke of a nation that could afford to be humane because it could afford to be strong. This was the ultimate revelation. The B-29 was not possible because America was wealthy. America was wealthy because it had created a system that made such wealth routine. The bomber was not the cause of victory. It was the symptom of a larger condition, the capacity to mobilize an entire continental economy without destroying the underlying social fabric. In August 1947, 2 years after the war ended, the Soviet Union revealed its copy of the B-29. The Tupolev Tu-4 looked identical because it was identical. Soviet engineers had measured every part, duplicated every process, built their own industrial ecosystem to produce a bomber they called the Bull. Stalin had demanded an exact copy, and he got it. The Soviets built 847 Tu-4s between 1947 and 1952. Not 10,000, but enough to create a strategic bomber force that terrified the West and launched the Cold War's nuclear arms race. The Soviets never matched American production. They could copy the bomber, but they could not copy the system that built it. Their economy remained, like Germany's, extractive and zero-sum. They built Tu-4s instead of consumer goods. They diverted aluminum from housing to bombers. They created a military-industrial complex that eventually consumed the Soviet state itself. America built the B-29, then built the B-47 Stratojet, then the B-52 Stratofortress. Each new bomber reflected not desperation, but evolution. The system continued. It continues still. The American bomber force today, descended directly from the B-29, represents a continuous thread of industrial and technical development spanning 3 generations. The German bomber force died with the Reich, a museum of might-have-beens. We must consider the counterfactual. What if Germany had built the B-29 first? What if German engineers had somehow solved the pressurization problem, perfected remote turrets, mass-produced reliable turbo-supercharged engines? Could they have built 10,000? The answer, based on the Haniva report's analysis, is no. Not because German engineers were inferior. They were not. German science and engineering in the 1930s and 40s were world-class, arguably superior to American engineering in many specific domains. German aerodynamics were more advanced. German rocket technology was decades ahead. German materials science was sophisticated and innovative. What Germany lacked was not knowledge but scale. They lacked a continental economy untouched by war. They lacked 2 million skilled workers who could be trained in months. They lacked a political system that could tolerate criticism and learn from failure. They lacked the time to build the factories before the bombs fell. The B-29 was not just a product of American engineering. It was a product of American geography, American democracy, American abundance. It required a nation that spanned a continent, rich in resources, protected by oceans, powered by rivers and coal and oil. It required a society that believed in mass production, standardization, and the inherent value of the individual worker. It required a culture that could turn the complexity of aviation into a repeatable process. Germany had excellence. America had capacity. In industrial warfare, capacity wins. The story of the German engineers who examined the B-29 and comprehended American potential is not just a story of one war, it is a story of the 20th century and beyond. It is the story of how industrial capacity became the ultimate measure of national power, how the ability to build complex machines in vast numbers became more important than the ability to build perfect machines